Good morning, doctor. My name is Yongki. Somcat matrix number DE 2026. Me myself represent my group mate, which is we are from group 1. So today we want to present the our work for assignment 1. So this is my group mates, which the first one is me myself Yongki, and the second one is Muhammad Alimin. The third one is Muhammad Iqbal. So three of us will divided the part to present each part. So me myself will present the for the task 2, which is the by using the YOLO part. I will present that one, and Muhammad Alimin will present the model 1, task 1, and Muhammad Iqbal will present the task 1 model 2.
Hello and Assalamualaikum warahmatullahi wabarakatuh. My name is Muhammad Bian Zulkifli. My matrix number is CA200126. So today I present the assignment 1 for model 1 task 1, which is this is the coding for the task 1 model 1, which is this is for Google Colab, which import from Drive. So I have run the coding, and then the result is in the slide presentation. This is the slide. So for the model 1, we got that have two graph, which is the graph is descending. So from the graph that we have done, the learning curve plot of the loss and accuracy matrix on the training and validation dataset. So the loss matrix measure how well the model fits on the data, and the accuracy matrix measure how often the model make correct prediction. So lower loss, that is, and the higher accuracy indicates better performance. So from the graph, we can see that the loss curve show a decreased trend for both training and validation dataset, which that means the model is learning from the data and reducing the error. However, the validation loss is consistently higher than the training loss. So which suggests that the model is overfitting the training data and not generalize as well to the new one. So for um, the graph at the accuracy curve show an increased trend for both training and validation, which means that the model is improved. The validation accuracy is consistent. However, the indicate that the model is overfitting and the training data is not performing well. So in the gap between the training and validation curve is relatively large and stable. That means the model has high variance and low bias. So this means that the model is sensitive to the noise and variability in the training. So to improve the model, that we find the solution and some strategy. So we need to use different data, to use more or different data to increase the diversity and representative of the training dataset. So next solution, we use regularization technique to reduce the complexity or flexibility of the model, such as dropout, which decay or it will stop. So we also need to use a different model, architect, or hyperparameter to optimize the learning process, such as changing the number of layers, neuron activation function, learning rate, or optimization. So for the model 2, Muhammad Iqbal will present the model. So that's all for me. Thank you. Assalamualaikum warahmatullahi wabarakatuh.
Assalamualaikum warahmatullahi wabarakatuh. My name is Muhammad Iqbal bin Muhammad DP. My metric number is CE200113. For my part is for task 1 model 2. What is the difference between the task 1 model 2 and task 1 model 1? For the task 1 model 1, we need to create our own filter, which is we use the 32 filter or 64 filter, and we need to set up our own header layers. And for the task 2 is for our project we use the VGG16. For the DL methods, is there a few other DL methods, which is like DeskNet, ResNet, and VGG16 or VGG19. For our project, we use the VGG16. So from the Google Colab, we import from the drive. So here is the dataset we import from the drive. So here is the coding for our project. And for the result we get is like this. Okay, here is the result that we get from the task 1 model 2. So the graph show like that. For the training validation losses and training validation accuracy. So the provide training log exhibit constantly patterns in both loss and accuracy metrics is over 100 approach. Unusual characteristic is the negative value observed for the both training and validation losses, which is typical in machine learning. The losses value could signal issues with the chosen losses function or underlying model architecture. Additionally, the fluctuating and relatively low accuracy value starting from 0.52 and 0.50 for the training and validation respectively, and reaching only 0.73 and 0.63 at the end, suggests the potential challenge in this learning process. This issue may arise from factors such as overfitting, inappropriate model complexity, or data-related problem. So to address this concern, several steps can be taken. First, in deep investigation into the choice of the loss function and model architecture in essential ensuring they are suitable for the problem. Hence, next is exploring adjustment in hyperparameter, simplifying the model, and verifying the integrity of the training and validation dataset for the proper pre-processing are crucial. Monitoring loss trend and experimenting with the different learning rates can be provide further insight. Debugging the training process by examining batch metric and evaluating the model on an independent test dataset can help to identify and rectify the specific issue, ultimately improving the overall performance of the model.
Good morning, doctor. My name is Yongkit Somkat, matrix number DE 2026. So for my part today, I want to talk about the task 2, which is we are using for YOLO version 8. So this is my flowchart. So we'll start and I'm using the Google Colab to do the coding and everything. So this Google Colab will link with the RoboFlow, and also we need to set up the YOLO to install the pip install and everything. Okay. Okay, so this is the result from the YOLO, which is it can detect the most accuracy is like 70% and also got 80%. So this is the sum of the picture that I annotate the picture from the inside the RoboFlow. Okay, next this is the test custom video by the YOLO. So as you can see, it can detect all the player, which is the player, and also which one is the referee, and also which one is the ball. It can detect, it can differentiate all of that because I already like annotate all of this in the RoboFlow, and then I connect it with the our coding to link with the RoboFlow. Okay, so this is my Google Colab. This is my program for the Google Colab by using the Python. So we need to select the GPU first, and then we need to install the YOLO version 8, which is in the coding, and then we need to import the YOLO, and also my program is connected to the RoboFlow, which is this is my API key, my token, and also chat ID to connect it to my RoboFlow, which is over here. This is my RoboFlow. So this RoboFlow, I import all the image from the YouTube, and then I annotate the image. That means want to trade wanted the program to recognize which is the player, the ball, and also the referee, where my program is to train to recognize for the football match, so that they can recognize the player, the referee, and also the ball. So all the picture that I annotate will save in the RoboFlow, and then it will be connected to the program. And then this is the training accuracy. As you can see, I trained for the 25 epoch. That means the training, the more the training, the decrease in the losses. So over here is the training accuracy. As you can see, it can detect the player, the ball, and also the referee. Let's try for the image. This one yes, for this one, which the player, the ball, and also the referee, which is 67%, and the ball is 47%. It can detect the ball. Yes, that's all from me. Thank you.
And lastly is for the conclusion. And to summarize, we developed the custom YOLO system to identify the person's UTHM, making the campus safer and more efficient. It aids in the real-time monitoring and counting of individuals at the stadiums. We utilize the YOLO computer vision framework to construct a diversified collection of over 300 features. So by doing so, we ensure that the system could manage a variety of scenarios, and the training phase, when successful, demonstrating that the technology can be adapted to the UTHM stadiums, and we tried it with the real footage, and it really works, demonstrating that is applicable for the common scenarios on the campus, by improving the organization and efficiency. Thank you.